From Los Alamos National Laboratory, this is the National Security Science Podcast.
The global nuclear landscape is not only more dangerous, but also more dynamic than it's been for some time. We must be ready to deter two near-peer nuclear powers within a decade. There should be no doubt in anyone's mind, NNSA is modernizing our stockpile on schedule and at pace.
Hello, and welcome back to the National Security Science Podcast. I'm your host, Brenda Fleming, and this is the podcast for the National Security Science Magazine. We are recording from Los Alamos National Laboratory in beautiful northern New Mexico. Today, our topic is deterrence, which was also the subject of our most recent magazine. In this podcast, we'll bring you some audio from a deterrence conference that our team attended. To hear more about deterrence and the role Los Alamos plays, check out our latest National Security Science magazine at lanl.gov/magazine. This issue includes feature stories on what deterrence is and how it's used, weapons effects, and some perspectives from people involved in the air and sea-based deterrence. So that's all in the magazine, but today we are going to talk about the Deterrence Conference. But before we do that, let's first hear today's Labcast, a minute to highlight current achievements at Los Alamos. Los Alamos National Laboratory is exceeding expectations in radiological and hazardous waste disposal. The waste includes protective clothing, tools, and equipment contaminated from nuclear weapons research and production. Los Alamos sent 68 shipments to the Waste Isolation Pilot Plant, known as WIPP, near Carlsbad, New Mexico. WIPP is the nation's underground repository for defense-generated nuclear waste. Lab officials say waste is moving off-site faster and more efficiently than ever before, which reduces any associated hazards to the environment, community, and workforce. Now it's time to turn things over to National Security Science writers Jill Gibson and Ian Laird.
Hello, I'm Ian.
And I'm Jill.
At the start of this podcast, you heard a brief snippet of audio from a conference that the entire National Security Science team attended. One brief note for this segment, because it was a conference and these were in large meeting rooms, there was a lot of background noise and rustling, and the audio quality might not be the greatest, so please bear with us through that.
But it is interesting listening. Back in the final week of January, we all flew out to Washington, D.C. to attend the 16th Annual Nuclear Deterrence Summit, a 3-day event that brought together leaders from the National Nuclear Security Administration, commonly referred to as the NNSA, the Department of Defense, private industry, other government agencies, and more.
Across the 3 days, there were nearly 20 panels, keynotes, and discussions about a wide range of topics from the geopolitical landscape to material procurement schedules. Leaders from Los Alamos National Laboratory were heavily involved at the conference. In this episode, you will hear from several of them.
You'll also get a chance to hear from NNSA Administrator Jill Hruby and General Anthony Cotton, the commander of U.S. Strategic Command, or STRATCOM, as it's commonly called.
Before we get started, it might be worth explaining the roles of NNSA and STRATCOM to better understand how Hruby, General Cotton, and their organizations fit into deterrence. NNSA is a semi-autonomous agency within the Department of Energy that, among other things, designs, maintains, and enhances the nation's stockpile of nuclear weapons via a number of sites, plants, and labs like Los Alamos National Laboratory.
STRATCOM, on the other hand, is part of the Department of Defense as one of 11 combatant commands. It's responsible for wielding the weapons designed and maintained by NNSA for strategic nuclear deterrence. STRATCOM also supports the other combatant commands with capabilities such as missile defense and intelligence.
With that settled, I think the best place to start might actually be with Hruby, because she said something early on in her talk that I think really encapsulated a lot of what the conference focused on. And one last piece of background info before you hear from Hruby, she will mention the Comprehensive Test Ban Treaty. That was a treaty signed in 1996 that banned all nuclear explosions, including tests, for both military and civilian purposes.
NNSA is being asked to do more than at any time since the Manhattan Project. This is true in all of our missions: the nuclear deterrent, nuclear nonproliferation and counterterrorism, and naval reactors. The global nuclear landscape is not only more dangerous, but also more dynamic than it's been for some time. This last year alone, Russia continued its destabilizing behavior by stationing tactical nuclear weapons in Belarus, de-ratifying its accession to the Comprehensive Test Ban Treaty, increasing its partnerships with Iran and North Korea, and vehemently rejecting arms control dialogue with the United States. In addition, China continues to modernize and expand its nuclear arsenal at a rapid pace, while introducing advanced technologies like hypersonic and dual-use technologies. As a result, both the U.S. Strategic Command and the Bipartisan Strategic Posture Commission are clear. We must be ready to deter two near-peer nuclear powers within a decade.
What Hruby alluded to in that clip is the idea that we now live in a world where there are three nuclear peers: the United States, Russia, and China. This was referenced either directly or indirectly by almost every speaker at the conference.
Right. I mentioned earlier that the geopolitical landscape comprised a large portion of the conference, and I think the fact that Hruby mentioned it up front says something about how it is informing the way NNSA is trying to operate.
The reasoning for that largely gets at something that General Cotton mentioned as well: the idea that because of the shifting geopolitical landscape and the rise of China, we just can't think of the current world in Cold War terms.
The methods we use to deter the Soviet Union, a single nuclear power that was not economically intertwined like we see in today's environment, requires a different integrated approach as we consider all strategic threats across the globe. As part of the joint force, STRATCOM's integrated deterrence strategy is the key component of a broader U.S. government and partner strategy to mitigate the global threats that we face. This strategy is underpinned by an unmatched network of alliances. Integrated deterrence is a whole of nation and a whole of government approach, combining our collective military capabilities with diplomatic, informational, and economic efforts. It's about utilizing layered and asymmetric capabilities, as exemplified by initiatives like AUKUS and partnerships in support of Ukraine, to promote increased security and stability.
Real quick, before we move on, you heard General Cotton mention AUKUS. One of the fun things about conferences like this is you get flooded with acronyms. In this instance, AUKUS refers to a 2021 Security and Technology Partnership between Australia, the United Kingdom, and the United States, which ultimately aims to deliver nuclear-powered submarine technology to Australia.
Yes, they do love their acronyms. But back to the topic at hand. General Cotton mentioned a whole-of-nation and a whole-of-government approach. Distilled to a single term, that's the idea behind integrated deterrence, using things beyond nuclear weapons, such as economic and diplomatic levers to deter aggression from other nuclear powers.
The diplomacy aspect was a big point of discussion at the conference as well. The idea of what arms control might look like with the advancements of China and Russia's secession from the New START Treaty, which imposes limits on the number of deployed nuclear weapons a country can have. Will Toby is the director of the Office of National Security and International Studies here at Los Alamos National Laboratory, and on this subject, he was asked a pretty pointed question about whether arms control is now dead.
So I think the prospects for the types of arms control that we have traditionally pursued are dim, if not dead. But I think there are other things that we can do. So if we look at the benefits of arms control in the past, it wasn't really that they reduced nuclear weapons. I would argue that arms control followed the natural balance of forces that the sides wanted to pursue in any event. So the SALT Treaty froze weapons at what their then current levels. The original START treaty reduced them somewhat, but I think both sides saw that they were going to come down. So what did arms control get us? I think it got us two things, transparency and predictability. Both of those objectives could be advanced by a different form in which the sides undertook verification measures to know exactly what each side had deployed and made their plans known in advance. It wouldn't be a perfect system, but it would in many ways finesse some of the problems that we face today, where how do we deal, do limits make sense in a two-tier world? Very likely Russia and China are not going to agree to a US force structure that's double each of theirs. We could have a treaty that would advance our interests that wouldn't necessarily involve limits, but would involve transparency and predictability.
I think this kind of helps move us into the next section of discussions that were held at the conference, and those focused on two things. What are we doing now to address this new world, and what other things could we explore that would strengthen our deterrent?
Those two questions are obviously huge, and there isn't necessarily a consensus right answer for either of them. And, as General Cotton mentioned, things can change really quickly.
Integrated deterrence is not static. It involves the changing national strategic landscape. It adapts to shifting international dynamics, technological advancements, and emerging threats. As we continue to navigate challenges and look for opportunities, integrated deterrence remains our guiding framework. It is not bound by integrated just nuclear capabilities, but rather all the enablers, support requirements, and other non-military levers of power to create desired effects.
If we're looking at current projects and capabilities, though, where would you want to start?
I think you probably know where we should start, given it got mentioned just under 1,000 times during the conference.
Program of record?
Program of record. Program of record refers to a directed and funded effort to acquire, modernize, or extend a current capability. In terms of the NNSA's program of record, this refers to things such as the development of the W-93 warhead and the modification and life extension programs for other bombs and warheads currently in the stockpile.
And this goes hand in hand with some of the modernization efforts going on at DoD, like the development of the Columbia-class submarines, Sentinel missiles, or B-21 Raider bombers, to name a few.
Right, all of this is building toward a more credible, modernized nuclear deterrent, as our two nuclear peers may be modernizing as well. Jill Hruby briefly touched on some of the progress that's been made in the past year for some of those programs on the NNSA side.
The Los Alamos plutonium pit production project, LAP4, continues to progress while developing qualified production processes for the W87-1 pit. In FY23, the Nuclear Security Enterprise completed 9 developmental plutonium pit builds, with 5 more pits assembled. And we expect the first diamond-stamped War Reserve pit for the W87-1 this year. On the Savannah River Plutonium Processing Facility, SRPPF, we continue with design and are simultaneously starting construction. Baseline cost and schedule updates and long lead procurements are underway. We have reconciled safety basis issues and put in place an NNSA first of its kind construction management contract. Our goal for SRPPF is aggressive. Complete construction by 2032 so that rate production can support the W93 schedule. On other large-scale projects, the Uranium Processing Facility, UPF, at Y12 is now over 70% complete. Glove boxes are installed in the main process building, and overall equipment deliveries are 96% complete. The High Explosive Science and Engineering Facility at Pantex and the ECSE project at NNSA continue. We intend to start other large projects in a realistic manner, assuming budget support. For example, we broke ground on the lithium processing facility at Y12, and initial site preparation work is underway with the construction set to begin in mid-2025. We are initiating a new approach for Kansas City expansion and have the high explosive synthesis and fabrication facility, production facility at Pantex and the tritium finishing facility at Savannah River in our sites.
A huge part of what Hruby mentioned there involves Los Alamos, and that's the pit production mission.
And for those that don't know, the pit production mission is an effort across Los Alamos and Savannah River site to produce new plutonium pits that will replace the aging pits inside of the nuclear weapons currently in the stockpile.
All timelines and indicators point toward the first war reserve pit being produced before the end of the 2024 calendar year. Up to this point, Los Alamos has only been producing developmental pits, but the plan is that this will be the start of producing the real pits designed to go into the stockpile. At peak production, the goal is to produce 80 pits between Savannah River and Los Alamos, with Los Alamos accounting for at least 30 of those pits and Savannah River producing the remainder.
The pit production mission at Los Alamos is occurring at a facility called PF4, which is and has been undergoing a significant renovation to prepare for pit production. This renovation and replacement of equipment has coincided with the developmental pit builds and other ongoing operations at the facility, making for a challenging and busy environment, as John Benner, the Associate Laboratory Director for Weapons Production, mentioned during a panel at the conference.
The installation of additional process equipment in PF4 is required to meet the 30 pit per year requirement. Installation of this equipment requires old equipment to be removed first as part of a D&D process, and doing this in an operating SCAT 1, Security Cat 2 nuclear facility is quite complex. Doing this in a facility while we are ramping up pit production towards an FPU in the next few months is even more so. The levels of coordination and cooperation in planning and operations required between production and construction are very significant. In several areas, we have production and construction proceeding in adjacent areas separated only by a few feet. In general, production is on the day shift, with construction on the second and grave shifts, along with maintenance. One strategy we are employing to better optimize both construction access and production are campaigns where we are shifting priority specific areas from production to construction to allow scope across multiple projects, both capital projects like LAP4 and MIE projects will all be executed at the same time in one large effort during a scheduled window of construction priority.
Another couple of acronyms to hit on there quickly. When talking about the D&D process for old equipment, that refers to deactivation and decommissioning. FPU stands for First Production Unit, so the first War Reserve Pit would be Plutonium Pit FPU. LAP4 stands for Los Alamos Plutonium Pit Production Project. And lastly, MIE projects are Major Items of Equipment projects.
Lots of definitions there. But it essentially boils down to a lot of work being done to try to hit benchmarks.
Right, or as Bob Webster, the Deputy Director for Weapons at Los Alamos, put it.
We're no longer just measuring things in some Gantt chart. We're counting the product arriving at the lab. And that's really a change from previous years. It's really good.
Now that we've established where the enterprise and the nuclear deterrent currently stand, should we look at some of the discussions about what could be next?
I think to start we should go back a few steps, though, and look at how we ended up with our current capabilities. Understanding their development process and the context around them, I think, is useful for informing the way we look at how we develop future capabilities.
That makes sense. Where do you want to start?
I want to return to something that I remember Will Toby mentioning.
For 30 years, we pursued a static deterrent and a static nuclear enterprise. We did that on purpose. We thought it was good for strategic stability. Strategic stability was a term that was used quite regularly in the 20 teens. We don't hear it very often now. And so I think part of what we need to do is realize, now we've gotten this role. Russia is invading its neighbors, China is digging holes to put missiles in them. We need to have a change in the way we pursue our nuclear enterprise.
How would you explain what he's saying there in the context of the nuclear stockpile as someone with some knowledge of the nuclear enterprise?
That 30-year timeline he mentions is key, because it just about matches up with the timeline for when nuclear testing stopped. During that time, we entered what's known as the stockpile stewardship era. And this is somewhat of a simplification, but stockpile stewardship amounts to using science to maintain and validate our nuclear weapons instead of using nuclear tests.
And when talking about the static nature of the enterprise during that time, the idea gets to another word that Toby used, stability.
Right. It was like the enterprise switched into neutral as it focused on maintaining the current stockpile and developing its scientific capabilities in a geopolitical environment that was relatively relaxed and stable compared to the Cold War. Now fast forward, and suddenly right now more is being demanded of the enterprise, and that requires a more agile NNSA.
And if we were to look forward, what exactly are we looking at in terms of capability development?
Along with following through on the program of record, which lays out years and years of production cycles, there was also a lot of talk about enhancing our scientific capabilities. That was something Los Alamos National Laboratory Director Tom Mason discussed.
Today, we used as part of our assessment processes facilities that were conceived at the end of the Cold War, investments that were made in facilities like NIF and DART. They are our bread and butter, absolutely essential. We need to apply that same kind of foresight and planning in looking at the deterrence challenges of the future and ask the question of what tools will we need 10, 20, 30 years from now. It's a difficult thing to do in the current environment because, of course, we're all consumed with the challenges of the modernization program. It's demanding a lot of mental bandwidth and a lot of financial bandwidth. And I think it's easy to say, well, all this scientific capability is really a long-term thing. That actually couldn't be further from the truth. These are the tools that we use as part of the way that we design, certify, assess the deterrent. And in fact, it's not long-term because the biggest impacts in terms of deterrent today come from understanding issues that arise in the surveillance program that drive us back to experiments at DART and our high-performance computers and all those other elements of that enterprise.
The facilities he mentioned, NIF and DART, are both state-of-the-art facilities that allow labs and sites across the enterprise to perform cutting-edge science on a regular basis.
And I guess what Mason is getting at there is that we can't get caught up in production cycles and let our scientific capabilities fall to the wayside.
Exactly. And he would later go on to say we've already invested so much into those facilities that we should continue to use and build on their capabilities. Webster touched on this aspect as well.
This is high precision, carefully manufactured stuff to do experiments that we never dreamed of being able to do during the nuclear testing period. And finally, we got Crossroads on here this year. There's a lot of focus on the high-end stuff like LCAP, which is going to be great. All of the labs have an amazing amount of computing that we do that's off of the high-end one. We have these capability machines. We are running computers every day to understand the interaction of the physics that we learn on these experiments. So, as Jill mentioned, we have an ongoing investment in this infrastructure. It is occurring. It's not probably where it needs to be in the long term. There is a real fear here of letting our scientific infrastructure atrophy.
You could hear Webster start to touch on it there at the end, where yes, we are at the forefront of a lot of things technologically, and yes, we are world leaders in many aspects. But things are evolving so quickly that there's a chance that you can get left behind very quickly if you don't press on.
Right. It's incredibly complicated balancing all of these things. But on the other hand, there's more than 80 years of history to show what this enterprise is capable of. and we've managed to meet the unique challenges of the past. To wrap up, let's turn things back to Hruby, who managed to speak to that very point.
The way I think about, every day I have to work problems, right? A lot of you have to work problems every day as well. But when you stand back and think about what we've done, and it's against the odds, right? We had to bring up facilities that had not been used for a long time. We had to, for example, at Los Alamos, do production alongside construction. We're using the tools we developed during the stockpile stewardship, era to do things that we didn't anticipate those tools would need to do. We're bringing things to modern standards with our digital engineering efforts. I mean, it's amazing what we've accomplished and a testimony to why we have the nuclear security enterprise. When I took this job, I recognized what we had in front of us. It's changed enormously, and by the way, it's gotten a lot harder. But we're stepping up. It's not like a well-oiled machine yet, but it is getting there, and it still takes a lot of hard work by individuals to make this all happen. In conclusion, I just have to say I'm incredibly proud of what we've accomplished in NNSA. We are delivering today, and we're creating a future enterprise that is responsive to global conditions. One thing is certain: we need the nuclear security enterprise to be at its best. We are being proactive, creative, and efficient with finite resources while delivering high-quality products on time.
Thank you, Jill and Ian, and a huge thank you to everyone who spoke at the conference and for giving their time and making this episode possible. As always, before we sign off, we will leave you with our highlights from the Hill. Los Alamos National Laboratory is helping bring indigenous college students into the field of physics. The lab has formed partnerships with Fort Lewis College and Navajo Technical University to provide mentorship and research opportunities to students interested in physics careers. The Fort Lewis program is called Engaging Indigenous Women in Nuclear Physics. The program is now in its third year, with 4 students from across the Four Corners region participating. The Navajo Tech program kicked off this fall and is open to both men and women. The lab is helping provide the university with equipment and is connecting students to research projects and experimental opportunities. Participating students will travel to Switzerland to conduct research at CERN, which is the largest particle physics laboratory in the world. Thank you so much for listening to the National Security Science Podcast. Don't forget to check out the National Security Science magazine online at lanl.gov/magazine to learn more about how better science equals better national security. For more great stories from Los Alamos, including several other podcasts, video series, and interactive stories, visit discover.lanl.gov. That's discover.lanl.gov.